This will be for the con exercise, distance between point and line. So just some notes real quick. The distance from a point to a line is the length of the perpendicular segment connecting the two. All right, so you'll see what I mean by that when we get to the problems. First problem, they want us to find the minimum distance between the point -1, 0 and the line y equals -8. Okay, so they gave us the point -1, 0 right here, and they gave us the line y equals -8 right here. And this type of problem, when the line is horizontal or vertical, it's actually very easy. In order to find the distance from the point to the line, you can just count, or you can do subtraction of the absolute value. So I'll show you both methods. All right, so starting from this point, we're going to count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this distance right here from the point to the line is just 8 units. So that's it. That's your answer. If you wanted to do it mathematically, we know that this is the y-axis. Okay, this point here is at y equals 0. And this line here, they gave us the equation, y equals -8. So the distance would be the difference between the absolute values. You would just take the absolute value of 0 minus -8. Okay, and 2 negatives in a row make it positive. 0 plus 8 is just 8. All right, and the absolute value would keep it as 8. So 2 ways to do that one, but the answer is 8. So just type 8 in the box. All right, find the minimum distance between the point 1, -3 and x equals -2. All right, once again, they give us the point 1, -3 and the line x equals -2. And we can just count 1, 2, 3 units. Okay, so the length of this distance is just +3. It's always going to be positive because it's a distance. And if you want to do it mathematically, this point right here is at x equals 1. And this line right here, they gave it to us in the write-up. This is at x equals -2. So take the absolute value of the difference. So the distance would just be the absolute value of -2 minus 1. All right, and that's the absolute value of -3, which is just +3. So that's what we said before, that would be the distance. So click in the box and just type 3. All right, this one's a bit more challenging. Find the minimum distance between the point 2, -1 and the line y equals -x minus 1. Enter an exact answer with a square root. All right, they give us the point and the line. I'll show you real quick. Actually, I'll show you right on the graph. All right, you want to find the slope of this line first. So you have to take 2 points on the line, and they have to be on the corner of the boxes, okay? All right, so the slope of this line, you want to grab 2 points on the line. All right, and this is, let's see, the slope is going to be change in y over change in x. All right, this is just the slope m. So that is the slope m. So change in y, we're going to go from one point to the other. Change in y, we go up 1, so that's +1 for change in y. And then change in x, we go left 1, so that's -1 for the change in x. All right, and 1 over -1 is just -1. Now the perpendicular slope, I'm going to write an M with a perpendicular symbol. Okay, that's an upside down T. It means I'm making a perpendicular slope. Okay, there's two steps to finding the perpendicular slope. You want to flip it and then change the plus minus sign. So since this is already a fraction, I'm going to use this. Let's flip it. So 1 over negative 1 becomes negative 1 over 1. That's the same thing. And then change the plus minus sign, so make it positive. So the new slope is positive 1 over 1, or just 1. Okay, that's going to be the new slope, or the new m. So we're going to apply that new slope to the point and the line. Okay, positive 1 over 1, that's the same as negative 1 over negative 1. All right, that's the same thing. So I'm going to go from the point to the line. I'll go down 1 and right 1. All right, I mean down 1 and left 1. So negative 1 means down 1, and negative 1 on the denominator means left 1. And now we're just going to use Pythagorean theorem. Okay, this side length here is 1. This side length here is 1. And then I'm going to connect right here, the point to the line. We want to find that line segment in black. Okay, this is a right angle right here. If you go across from your right angle, that's C. All right, so we have a right triangle with two legs of 1 and 1. I'm going to draw a bigger version of this. All right, this side length was 1 and this side length was 1. Across from your right angle is the hypotenuse C. So we just use a squared plus b squared equals c squared. Okay, the legs, it doesn't matter which is a or b. The hypotenuse always has to be c. All right, so a is 1 and a squared is going to be 1 squared. B is 1 and b squared is going to be 1 squared. And that equals c squared. 1 squared is 1, so 1 plus 1 is just going to be 2. And that equals c squared. And taking the square root of both sides, the square root of c squared is just c. And they said we can leave our answer as a square root. So it's just radical 2. So click in the box, click on the radical symbol, and type 2. That's it. All right, one more. They want us to find the minimum distance between the point negative 2, 6 and the line y equals 1/2 x minus 3. Enter the answer as a square root. All right, this time I'll get the slope from the line equation itself. We can see that the equation is in the form of y equals mx plus b. So m is the slope, the number multiplied by x. And we can see right here that m equals 1/2. So now we want to find the perpendicular slope. So I'll write m with a perpendicular symbol. Okay, upside down capital T means perpendicular. And there's two steps for this. To finding the negative reciprocal, you want to flip it. So 1/2 becomes 2 over 1, and then change the plus minus sign. So that's negative 2 over 1. And this slope translates to down 2 and right 1. All right, so we need to follow that from the point to the line. We need to follow that slope. All right, so let's apply that. Down 2 and right 1. So here is our point. I'm going to go down 2 and right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. And there's our point right there. Okay, you can use Pythagorean theorem, or you can use distance formula. I'd rather use Pythagorean theorem. All right, so I'm going to construct a right triangle. We're going from this point to this point. So we have this distance here, the vertical part, And then we have this distance here, the horizontal part. Okay, and this is a right angle. This is going to be a right triangle. All right, and the distance from point to point, I'll do that in black, is going to be the hypotenuse. All right, so across from your right angle is going to be C, your hypotenuse. All right, the other sides are just A and B. So we're going to do A squared plus B squared equals C squared. All right, C always has to be the hypotenuse. A and B are just the legs. It doesn't matter which is which. So let's count. We're going 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this length here is 8, that side length of the triangle. And this one here, 1, 2, 3, 4. That side length is going to be 4. So I'll let A equal 8, and I'll let B equal 4. So A squared is going to be 8 squared. B squared is going to be 4 squared. And that equals C squared. 8 squared is 64. 4 squared is 16. And that equals C squared. 64 plus 16 is just 80. And that equals C squared. Solving for C, the opposite of squaring something is to take the square root. Square root of C squared is just C. And C equals radical 80. So that's the distance between the 2 points. So just click in the box, click the square root symbol, and type 80. So it looks like you don't have to simplify the square root. You can just type radical 80, and they will accept it. So you don't have to simplify that square root.